Hello class. So we will be talking about uh, midterm review here. So given that f of x and f prime of x and f double prime of x, they're all negative, then what does that mean? The first, f of x is negative, that means the graph has to be below x-axis. So therefore this cannot be it. F prime is negative, that means it has to be decreasing function. That means these two cannot be it. Now, then the second derivative is negative, then throughout everything it has to have negative concavity. Here is the positive concavity. Therefore, only correct answer will be choice B. All right, let's look at the next question here. Continuous but not differentiable. Continuous but not differentiable has to be corners or cusp, such as this portion. Here, not continuous because of the hole. Here, there's a jump. So therefore, that cannot be it. And this one is purely just continuous and differentiable at point E. So therefore, our answer will be choice A. All right, so next question here. Which of the following is true about F? Now, what I'm going to do is I'm going to make this one a bit smaller. All right, so here we have F is increasing, or F is decreasing from -1 through +1, but in fact you will realize that this is graph of F prime. In order for that to decrease, that means F prime has to be negative. That's not the case. F is increasing from -2 to 0. In fact, that is correct because that means F prime has to be positive, and we see that to be true. F is increasing from 1 through 2. In fact, F prime is negative here. So therefore, it must be decreasing, even though it looks like increasing of the F prime. Remember, this is graph of F prime. And local minimum, no, actually, it has local maximum because positive to negative. F is not differentiable. In fact, it was differentiable. That's why we were able to figure out the value of the differentiated function, meaning the derivative, at -1 and 1. So F must be differentiable. All right. Here, let's try to look into this one. Number 4 and number 5, I want you to think about the definition of limit, where limit of as h approaching 0 for the expression of f of x plus h minus f of x over h. Now, here when you compare, you will realize that the numerator should give you a nice hint about what f of x would have been. Because this expression is ultimately equal to f prime of x. Then in order for us to get this one, we first have to know what f of x is. F of x here, it seems to be 1, but in fact the structure comes from here that we can guess for number 4 that f of x must be the expression, whatever that is, to the 6th power. And that makes sense when x equals 1. Then what is the derivative of f in this case? It brings 6x to the 5th power. Now, but in place of x, we have 1, as you can see. Therefore, f prime of 1 is simply now equal to 6. Therefore, C will be our answer. Here, number 5, what would you get for the f of x? From the same idea. That's right. When you look into the structure of the function, it should have been cube root of x. And you can see that from here. And you will notice that the value of x in front of h must be equal to 8. And that's basically what we're looking at later. Then, if you have to rewrite this one, here that's equal to x to the 1/3 power. Then what is f prime of x? In this case, will be 1/3 times x to the -2/3 power. Now, in other words, this will be 1 over 3 cube root of x squared. That's what we end up getting. Once you plug in 8, then what's going to be happening? Yes, this will becomes 1 over 12 when you plug in 8 in place of x. Therefore, our answer will be choice. How about number 6? Number 6, in fact, yes, f of x, same idea, must be ln of x. But you can see that in place of x, we have e. Therefore, ln of e here becomes 1. That makes sense. That means what is f prime? F prime here becomes 1 over x. But when x equals e, then we get 1 over e. That's our answer, right over here. Here, let us look at number 7. In case of number 7, we can look at this one as a this way, where f of x, in the same manner, f of x can be cosine of x. Now, you might be wondering, how could it be possible? Because in this particular case, you can replace x with h, and then you can remember to see, you can try to see something like this: cosine of h minus 1 over h. As h approaching 0, the limit. It might be a bit easier for you to see, because cosine of h, that means here we are looking at x value will be equal to 0, because when cosine of 0, we get 1 right over here. So therefore, what is f prime? Then it becomes cosine of the derivative of cosine becomes negative sine of x. And once you plug in 0 in place of x, we'll end up getting 0 over here. Another way for us to approach this one would have been multiplying top and bottom by cosine of cosine plus 1. Then you will also get the same value. All right, let's look at number 8 together. So here we have many different pieces of information given. Now let f be the function that is continuous from 0 through 4. We don't have the value 4, but we can see what's going on over there. And function is twice differentiable, except now, when the function is not differentiable when x equals 2, that's very important because it must be the cusp corner or not continuous. Oh, but it says continuous, so it has to be cusp or corners. Now, the function f is derivative has its derivative have the property indicated, a table above. We can see that over here. Now, for 0 to 4, find all values of x which f has relative extremum and determine. So in this case, we are looking at for critical values. Critical values. What are the critical values when f prime has to be equal to 0 or not defined, which would be right over here and right over here. Now, but when x equals 1, about that value we have positive to positive. So therefore, there is no relative minimum or maximum. It has to change its sign, such as here. So when x equals 2, we get to realize the derivative goes from positive to negative, then positive to negative. So we get to see relative maximum. That's what we get to see. Now, B on the axis provided gets the graph. Now, so first, what we like to do is we like to plot those points first. How about that? So when x equals 0, it was negative 1. I'm going to bring this one down a little bit more. And then 1, it was equal to 0. And 2 equals 2. And 3 equals 0. Now 4, we have no idea what's happening, but let's see the story behind it. Now, next one is this, negative and positive. See, second derivative is negative, first derivative is positive. Then my recommendation is go for the second derivative first. It will give you a basic sketch. For example, here negative and positive, that means first we have negative concavity, but first derivative is positive, therefore we are increasing. That means we are looking at rather this section right over here. So therefore, from first point to the second point, we're going to have a graph that goes up this way. Now, from second point to the third point, here both of them are positive. That means we're looking at positive concavity and then increasing. So we are looking at going up this way. And third one is negative, negative. So then it would have been this portion where negative concavity and going down. So we are looking at going down this way. Oops. It's going to go down this way. Okay. And then the last one is concavity is positive but still decreasing. So we are looking at this portion. So if I photograph it further, something like this. That would have been our answer. All right. Number 9. All right, so let's look at number 9 together. First one is we have to show that taking the derivative of this one will give us this. Now, how are we going to do it? Let's try to do this one together right over in this section. And we have derivative of y squared respect to x would have been simply 2y prime. Here y prime is dy over dx. And then derivative of 2 becomes 0. Plus derivative of x times y is, in fact, product rule applies to x times y prime plus simply y. Now, we see the y primes on these two terms, so bring this one over. So we have 2y y prime minus xy prime is equal to y. By factoring out the y primes, then we have y prime is equal to y, which was already here, divided by 2y minus x. And that's how we can do part A. Now part B, find all points of x comma y on the curve where the line is tangent. We want to find out the value of x and y value, but has a slope of 1/2. Now slope is 1/2, that means we have to use the first derivative here, b, which I'm going to read right over here, say 1/2, then must be equal to first derivative, which is y over 2y minus x. That means when we plug in the values, or cross multiply, we get 2y minus x must be equal to 2y. Then by subtracting 2y from each side, we get to realize that negative x is equal to 0. That means x must be equal to 0. Now, then we know the value of x, but how are we going to find the value of y? From the original expression. So what we're going to be doing is plug in 0 for x. Then we get to see y squared is equal to 2 plus 0. Then y, and we get to see to be plus or minus. We have two values, square root of 2. Now then, 2 points that which we are looking at is 0 comma square root of 2 and 0 comma negative square root of 2 could be our answer. Now, number C, show that there is no point of x comma y where this curve, on the curve where the line tangent to the curve is horizontal. That means C, horizontal means the slope y prime has to be equal to 0. That means y over 2y plus minus x now. Then in this case, we get to realize, in order for that to happen, we get to realize y has to be equal to 0. And then only then the fraction will be equal to 0. Now, let's see if that's possible or not. Then in place of y's, we're going to plug in 0. Then we get to, this translates to 0 squared is equal to 2 plus x times 0. Now, then as you can see, in this case, we get to realize that then 2 must be equal to 0. But 2 cannot be equal to 0, you see? Contradiction, therefore, y cannot be equal to 0. That means this will never be equal to 0. Now, number D. Let x and y be the function of the time t that are related by the equation in this way. So that at time t equals 5, value of y is equal to 3. All right. And dy over dt is equal to 6. Find the dx dt. So what we have to do is this. One thing that which we get to realize is dy dt, in fact, is equal to, what was the value? 6. And then dx dt is what we like to find out. And when t is equal to 5, y value was equal to y value was equal to 3. Now, we like to do this one. First way which we like to do it is using the first derivative, because the way which we can get dy over dx, how about this? dy over dx is what we know from this expression earlier. Now, but if you divide, if you multiply top and bottom by dt, 1 over dt, then we get dy over dt, which over dx over dt would have been also equal to this one. So now, one thing that which we get to realize is this: dy dt is equal to 6, and dx dt we have no idea. That must be equal to when y equals 3. So we know that we can plug in y equals to 3 in these two locations, but how about x? We can figure that out by looking at the original equation. So 3 squared is equal to 2 plus x times 3. Then here we have 7 equals 3x, where x becomes 7 over 3. So then we end up getting 3 over 2 times 3, and then minus 7 over 3. If you multiply top and bottom by 3, we get to realize 9 over 18 minus 7, which ends up being 9 over 11. Now, then that must be equal to this one. Then we end up getting, by cross multiplication between dx over dt times 9, must be equal to 66. So therefore, dx dt, and it is equal to 66 over 9, which is equal to 22 over 3. Now, that's the first way which we can get it. Second way is doing it directly from the beginning. For example, both terms are in terms of time, so what we get to realize here was, this is the second method. Since y squared is equal to 2 times 2 plus x times y, then let's take the derivative against time from the beginning. Here we get 2y dy dt is equal to 0 time plus x times dy dt plus, here we end up getting y times dx dt. Then what we get to realize is, we know many values, and then we will realize the value of x was equal to 7 over 3, using the same thing as to the earlier one. Right? Then we get to see that 2 times 3 and dy dt was 6 is equal to x was 7 over 3 times dy dt was 6, I believe. Right? And then plus y value was equal to 3 and dx dt. Then we get to realize that here, this portion is 36 equals, becomes 14 plus 3 dx dt. This is almost like a related rate kind of question. And we get to realize 22 is equal to 3 times dx dt. Then dx dt will be equal to 22 over 3, same as before. All right, let's move on. Number 10. So, for which of the following does the limit as x approaches 4 exist? That means in order for this one to happen, left limit and the right limit has to be equal to each other. Meaning they have to approach same value. Here they are approaching this particular value, So is this one. They're approaching the same value, so this one is okay. 1. How about number 2? Same thing. They're approaching same value. You see the approaching, not what the value is, what they're approaching. That's important. The second one also works. On the other hand, third one goes here. From the right side, we end up getting another value, so third one is not. So our answer is first one and second one only. Now, let's look at the next question. Now, second derivative of the function is given in this way. For what values of x does the graph have point of inflection? Point of inflection is where the concavity changes from positive to negative or negative to positive. And we see that right over here, about a positive to negative concavity changes, meaning the double derivative goes from positive to negative or negative to positive. Another one is right over here. But at b, we realized that the second derivative was positive, and then after b, also still positive. So only two possibilities will be a and 0, which is the choice 1. All right. So now this is a calculator question, and we will continue this part from next video. Thank you.